All right, I'm going to show you two processes from section 7.7, how to write exponential and power functions. So we'll start with exponential functions. The fundamental relationship being y equals a times b to the x. There's what we end up with is what we start with times the growth or decay factor raised to the number of cycles. So just like writing an equation for a line, I have 2 points, and I am going to label those x1, y1 and x2, y2. Your book then shows you how to do it a little differently. I like to write a proportion. So for example, if I have y1 equals a times b to the x1, and y2 equals a times b to the x2. So if I wrote that as a proportion, I would say y1 over y2 equals a times b to the x1 over a times b to the x2. And my a's cancel, so I get y1 over y2. And what do we do with exponents when we have a common base? We subtract them. So this is just b to the x1 over b to the x2. Now I am going to tell you I could also write this as y2 over y1, and that's b to the x2 over b to the x1. I can flip the whole proportion. And what matters is I want my higher exponent to be on the top. So how does that shuffle out here? I want my higher x value on the top. So I actually want to use this proportion. So my y2 is 2 over my y1 is 8, and my x2 is 5. So in other words, 2 comes out when 5 goes in, and 8 comes out when 3 goes in. So 2 over 8 is b to the 5th over b to the 3rd. And why do I like that? Because when I subtract exponents, I get a positive exponent, b squared. And what squared is 1/4? Well, b must be 1/2 then. And so now I come back to this fundamental relationship. Y equals a. Now I know b is 1/2 to the x. And then you can choose either point, just like in an equation for a line. I'll use this one. 8 equals a times 1/2 to the 3rd. 8 comes out when 3 goes in. And then 8 equals a times 1/8. So a must be 64. So the question is, write this relationship, y equals a times b to the x. I found my b, I found my a, and the relationship then is y equals 64 times 1/2 to the x. I started with 64 teams in the tournament, and through every cycle we only have a half left, or every set of games there's only a half of those teams left. I'll do another one. And again, I guess it doesn't matter what you call x1 and what you call y1, but we're writing a proportion, and I'm not even going to number them this time. So y over y, and again the a's cancel. Just make sure that this y and this x go together, and this y and this x go together. And I want this x to be the bigger x, so I guess I should be putting 2's. 2's on the top. 1's on the bottom. And then I get 324 over 9 equals b to the 4th over b squared. And again, I have, if I subtract, I get b squared equals 324 divided by 9 is 36. That's a nice number. So b must be 6. And then I need to go back and find a, and I go back to my fundamental relationship, and I know that when y is 9. I know b is 6, y is 9 when x is 2. So 9 equals a times 36. So a must be equal to 1/4. Divide by both sides by 36. So y equals 1/4, 6 to the x. So that's how to write an exponential function. I like to write a proportion. Your book shows you how to do it a little bit differently. And when I write my proportion, I like to make sure my higher exponent is on top. And remember that whatever x you put here, that y goes with that value. All right, so let's write a power function. Similar process, but different relationship. This is y equals some value times x to some power. So the two things I'm looking for here are that value and that value, sort of like slope and intercept. With an exponential function, I'm looking for this value and this value, that a and that b. With a power function, I have a coefficient and then I have a power. So x1, y1, x2, y2, and I set up my proportion, y over y is equal to a times x to the b. And then I'll put 2's here and 1's here. So 36 over 4. And again, the a's cancel, is equal to 3 to the b over 1 to the b. Now no matter what you get here, if I have m to the b over n to the b, that's the same as m over n to the b. So 36 over 4 is 9, and I can write this as 3 over 1 to the b, which is just 3. So 3 to the what equals 9. B must be 2. And so now I know what b is. I can go back and find a. And these numbers are sort of simple, so let me try 36. 36 equals, I'm looking for a, and I know x is 3, and now I know b is 2. So 36 equals a times 9, so a must be 4. So y equals 4x squared. That was simple. Let's try one that's maybe a little more complicated. X1, y1, x2, y2. Remember, this is the fundamental relationship I'm looking for. I set up a proportion. A's cancel. 16 over 2 is equal to 5 to the b over 2 to the b. And again, remember 16 over 2 is 8. I can write this as 5 over 2 to the b. So 8 equals 2.5 to the b. Now I don't know what this is. It's in the other one it was easy. 3 to the what equals 9. Well, that's just squared. Here I would natural log both sides, or log, whichever you prefer. And then that b is going to come down front. That's the beauty of it. And then I can divide both sides by ln 2.5. ln 8 divided by ln 2.5 gives me 2.27. We have numbers that aren't quite as nice, but it's fine. So y equals a times x to the 2.27. I want to find a, so I plug in a known x and y. Just as easy to use 0.1 because they're both 2's. And then a will just be 2 divided by whatever 2 to the 2.7 is. And that works out to be 0.41. 0.415. So y is equal to 0.415 x to the 2.27. Writing exponential and power functions.